So why electrons matter? So I'm going to show you, this picture is showing you a shell model, and this is a different type of model. Like I said, it's not always going in circle, it can be going in pear shape, the electrons around the nucleus. So these are different things or different models that we use to understand them for educational purposes. This might not look the same under the microscope or at subatomic level as it looks to the naked eye. So this is a shell model. Here's the nucleus, and there's a shell of electrons going around. That's the inner shell. You can see there's another one going around. That's the outer shell. So outer shell is unstable or more unstable compared to inner shell. In other words, inner shell is more stable compared to the outer shell. Anytime if there are two shells there and atoms, if they're gaining or losing electron, it's going to be from the outer shell. So that's the outer shell. Or even if they're sharing, they share in the outer shell because the inner shell is more stable compared to the outer shell. Does that make sense? I don't want to confuse you guys. I think I said it too many times. Okay, so here is the first shell, hydrogen atom showing one electron, and here's helium showing two, and it can gain more and more shells as the number gets higher. So you can see more here in this compared to here, and they can share electrons. So let me see if next part is showing that. I think that's coming up. So here we have first shell, it's going to increase depending on the number increasing. Here's the third shell, the argon has 18, so it increases in number. But compared to the electrons found in this shell, these are less stable. So these are more stable, these are less stable. If they were to share, lose, or gain, this is the shell they would be doing it from. And here, this one is less stable compared to this one. So atoms, they carry a charge because it has an unequal number of protons and electrons. And anytime they lose or gain electrons, it's called ion, I-O-N, ion. Negative ion, because electrons are negatively charged, that means it gained an electron. So that's a negative ion. You have two protons that are positively charged, but you have three electrons that are negatively charged, so you have a negative ion. Positive ion, if that means it gained maybe it lost an electron. That means there's less electrons, so less negative compared to positive, so that's a positive ion. So here atoms that carry a charge, so they can be either, can come from gaining an electron or electron loss. So here we have a sodium atom, basically. So it lost an electron. So the charge is 0 now because the electron was negatively charged. It has 11 protons. And here, now you have a positive charge because after it lost the electron because the electron was negatively charged. If it gains an electron, because it's negatively charged, it's going to gain a negative charge there. I hope this makes sense. Does this make sense to you guys? If it's losing an electron,
Yes.
it's becoming more positive. Yes. Okay, so now we're going to talk about chemical bond. Here we have oxygen, and that's an atom, and it's bound to hydrogen. It's sharing electrons with hydrogen, and that makes a molecule. We have a water molecule here, and that happens because of a chemical bond. So attractive force that can arise between two atoms. This is an atom, this is an atom, and their electrons interact. That's a chemical bond. So we talked about molecule during last chapter 2. So that's basically two or more atoms coming together. That makes a molecule. So we have hydrogen and we have oxygen coming together. That's a molecule. And they are joined together by a chemical bond. We will be talking about 3 different chemical bonds. And then we have a compound. So molecule, it can be 2 or more atoms coming together. It can just be 2 oxygen atoms. 2 oxygen atoms come together, that's a molecule. If it's a molecule that has atoms of more than one element, again, element is a pure substance. So if it's oxygen and hydrogen, that's a compound. If it's just 2 oxygens or 2 hydrogens, that's a molecule. So I hope this makes sense to you. Molecule is two or more atoms joined by a chemical bond. It can be two oxygens, it can be two hydrogens. Compound is going to be two different ones. So more than one element. That means there's oxygen and hydrogen. Three types of bonds I want you guys to know. I think in chemistry you might have to know more, but the three types I want you guys to know for this class are covalent, ionic, and hydrogen. So those three. Okay. So those three, covalent, ionic, and hydrogen. I will go ahead and explain these. So covalent bonds, two atoms sharing a pair of electrons. So maybe two hydrogen atoms sharing, and that's what it looks like. That's what it looks like. It can be sharing more than two. And this is another linear model that they use in chemistry to show when there is a covalent bond where they are sharing the electrons. And then it can be maybe, again, 1, 2, 3, or 4 covalent bonds, depending on the element you're talking about, depending on the bonds between the types of elements that are there. Very important one is a polar covalent bond. Polar covalent bond, they share the electrons unequally. So what does that mean? Here in this photo, we have oxygen, and then we have two hydrogens. You have two positive charges, and then you have oxygen that's negatively charged. So they're unequal. So that makes a polar covalent bond, and that's a water molecule. So this is really, really important. If there was, the water didn't exist, there was no polar covalent bond, life would be, here today. So water is really, really important for life. Non-polar covalent bonds, atoms, they share electrons equally. So here it's 2 versus 1, if you want to think in those terms. If it was non-polar, it'd be just 1 and 1 maybe. So water is a polar covalent bond. So in this chart, we have a common name, that's water, chemical name, dihydrogen monoxide. Have you guys heard about dihydrogen monoxide meme or a joke? You guys heard about that? No? So I think the way it goes that you prank call a news company or radio station and you tell them there is a dihydrogen monoxide coming out of faucet. And because it's a really long name and people maybe they didn't take chemistry or they don't know what this means, they kind of freak out. They think it's something dangerous. Let me see chat. No. And then so that's the joke. Dihydrogen, di means two hydrogens, mono means one oxygen. Basically that's water. So that's the chemical formula for that. This is the structural formula for that. This is a structural model. This is a shell model. So this chart is basically showing you different models and how you can write these. Also, there was another one. I was talking about critical thinking earlier today. I don't know if you guys heard about this. Have you guys heard about this before? 1/3 of burger? No. So people got really confused when this came out. Why? So they thought that 3 is higher than 2. So they were getting confused why this is costing them more versus this, because they didn't really understand the math there. So that's another one that was in use. So that's the covalent bond. Ionic bond is it's a mutual attraction between ions of opposite charges. So earlier I said opposites attract. So positive is going to be attracted to negative, South Pole versus North Pole. So here sodium is positively charged and chloride is negatively charged. So the opposites attract, that makes an ionic bond, and it gives us table salt. So that's table salt. Tell me if this is a molecule or if this is a compound.
It's a molecule. Or correction, sorry.
What is it?
Molecule.
Molecule. So sodium is a molecule or sodium atom. So when two different elements come together, so if it's just one pure element like gold, and if there were two gold elements, that would make a molecule. But if it's two different elements coming together, that makes a compound.
Compound. Yeah.
Compound, yes. So everybody in the chat said compound. That's good. So make sure you guys understand the difference between those two. So I think I gave you guys a lot for today. I want to stop here. I want to cover the hydrogen bond next time. So this is going to go into hydrogen bond.